Okay, we want to go over the concept of atmospheric stability. Now, it's very, very important. Go to your mastering page, your student page, and find the study area. Go there, find chapter 4, go to chapter 4, and look in the animations. And there's two animations you're going to need to watch there. The water phase change, but the important one for this part of the lecture is make sure you watch the one on atmospheric stability. It's going to go into this topic in a lot more depth than I am here, but it's important to understand for pretty much the rest of the semester when we're talking about the atmosphere, okay? So make sure that you watch those two animations. So it would really give you a much better understanding of how this process works. Okay, so basically you have an air mass and it's either going to rise up or it's going to sink. It's going to rise up because of buoyancy and sink because of gravity. If it remains in the same location in the atmosphere, then it's what we call stable. It remains in place. So air that is warmer than the surrounding environment is unstable. It will rise. Air that is colder will sink, and it's what we call stable. Okay, and hot air balloons are a really good example of this process. If you add more hot air, it goes up. If you take some hot air away, decrease what's in the balloon, it will sink down. So rising, if it's unstable, the rising air parcel cools more slowly than the air around it, so it's more buoyant, and so it goes up. If it's stable, the air parcel cools more quickly than the air around it. It becomes denser, and gravity wins, and it's held down or pulled down a little bit. Okay, now this is very important. When the air mass ascends, as the air mass rises, it expands because of the decreased air pressure that we talked about last week, and it will cool because of the decreased kinetic energy, lower density. The molecules are more spread out. They don't bump into each other as much, so there's less kinetic energy, and they cool down. So cool by expansion. If the air mass descends, it is compressed because of the increased air pressure, because remember, air pressure is greater at the Earth's surface, and it will therefore heat because of the increased kinetic energy. It's a higher density, and the molecules bump into each other with more frequency, so the temperature goes up. And moist air cools slower than dry air because of the latent heat of condensation. So that means to cool the air, if it's moist, you have to first cool the moisture itself, and then you cool the air parcel. So it takes a little bit more time than if there's no moisture in the air. Then you just have to cool the air parcel itself, okay? And we call this the adiabatic process, okay? Now, again, I want you to watch that animation. It's going to go in the study area. It's going to go into this in a lot more depth, so make sure you watch this. It's going to go into the lapse rate. Normal lapse rate is 6.4 degrees Celsius per 1,000 meters, or 3.7 degrees per 1,000 feet. And what we call the adiabatic process, the change in temperature of moving air parcel without a loss or gain of heat, where there's no heat exchange. So you're either rising, cooling by expansion, or sinking down, warming through compression. Okay, and again, this is in your book, and it's also in the animation. So just pay attention to that. As you go up, lower air pressure, we cool down. As we cool by expansion. As we go down, air pressure is greater, the parcel condenses or compresses, and we heat up. Okay, so that's basically what it is. We're cool by expansion, heat by compression. No exchange of heat energy. That's the important concept. So in your book and in the animation, again, dry air is going to cool quicker because there's no moisture that you have to cool first. Whereas down here, so notice the difference. It'll cool at 10 Celsius per 1,000 meters, and if it's moist, it's only 6 degrees per Celsius because you have to cool the moisture first. And again, this is explained in the animation, so make sure you watch this, or watch the animation. Okay, and so this is in the book too. So again, notice as the air is dry, it cools quicker, and then as we go up, it takes a little longer for it to cool down by expansion. Now, let me, okay, so we'll stop here and I'll go into this. I should have reversed the slides here and I didn't, but we're going to go into processes that lift the air because that's how we get air up into the atmosphere to warm up or cool down. Okay, so again, watch that animation on in your study area. So go to your MyLab Mastering, go to your page and scroll down and you'll see a link to study area. Click on that. Up at the pull down menu at the top, find chapter 4, click go, and it'll display the animations and watch the water phase change, and especially this one, the atmospheric stability one. Okay, so again, make sure you do that.